Right, today we're going to look at inverse functions and how we can graph them. For this course, we don't really need to be able to work out algebraically how to do inverse functions, but we do need to be able to work out how to draw an inverse function from the graph of the original function. Now, if we look at this green line here, we can see that we have got our function y equals 2x squared plus 3. And if we do our vertical line test, we can see it only crosses once at any one point, so therefore it is a function. Now, to find the inverse function, effectively what you do is you swap the y and the x around. So if we look around now, what happens when we switch the x and y in variables, we get the graph over here. The only problem with this graph, although it's the inverse of our green function, it's no longer a function because it doesn't pass our vertical line test. So what I need to do is I need to restrict my domain of my original function. So I'm going to just change my domain so my original function only goes to here. And therefore, for my inverse function, I get this result. Notice I've swapped the x and the y's round for the inverse and the function as well, so as to get the same values being plotted. So this blue line is now the inverse of my green line. Now essentially the reason why the domain switches round and it's the range I get over here is the domain of this function is the range of this function. Okay, and the range of the green function is the domain of my blue function. Another way to look at how we can get our inverse function is to realize that we can find them by just reflecting the line y equals x here. So if we see this line here is a reflection of that line in the line y equals x, this is the line y equals x. You can also see that the point 0, 3 has flipped to 3, 0. And over here, so let's see if I can get it. Not so easy to get. There we go. The point 1, 5 will flip across to the point 5, 1 just here. Okay, so therefore the coordinates also flip round because the y and x's flip round. And that's how we can draw our function. Okay, let's just go back and let's have a look at how we would do this using our graphical calculator. I'm just going to just quickly move up and just delete the y equals x function just as it's out of the way for a minute. Okay, and I'm going to draw this. So this is my original line. We can also, if we go back and put the y equals x in again, so we're going to just do that and draw that. We can see our line y equals x here. So the inverse, the blue line was our original function. Now if we want to draw our inverse function, okay, what we need to do is we need to reflect the blue line in the y equals x line, which is the red line. So I'm going to now just take this point here, which is minus 2, 3, and it's going to become minus 3, 2. So it's going to draw from there. Now what you'll notice is they all cross at the same point. So our new line becomes here. So we can see there's the line y equals x. The blue line, the black line will cross it exactly the same point because that's what happens in reflection. We can see the point 0, 1 becomes 1, 0, and so on. So we can use our graphical calculator to help us do that. Although unfortunately on our graphical calculator we don't have this sort of line function that I've drawn in here. Right, moving on to the sorts of questions that we tend to come across. We want to explain why the function f-1 exists. Well, this function exists because this is what we call a one-to-one mapping. For an inverse function to exist, the original function needs to be a one-to-one. If we go back to here, remember we had to swap. This was a graph that went over here. If I can just get rid of these values here. Okay, we have here what is called a many-to-one mapping because you're going to get two values. Okay, the value here where you've got 1, 5, and you've got the value here minus 1, 5. Okay, both giving you the same value. And then if you plot the inverse, you'd get a function looking like this, which wouldn't satisfy our line cutting, vertical line only cutting at one point. Therefore, it's not a function. So we need to restrict our domain to a one-to-one. So the reason why this is can have a function is because f of x is a 1-to-1 mapping. Okay, for each value we put in, we get just only one value out. Right, let's try and sketch the inverse function on here. So first of all, what we could do is we could just put in our line y equals x, which will go roughly from here through the origin and up here. So here's our line y equals x. Now we're going to reflect this point over here. So what was -1 minus 5 will become -5 minus 1 and will end up here. And this point 4, 2 will become 2, 4. Swap them around and it'll become up here. Let's look for another good point. So another good point here is 2 minus 3. Okay, it will become -3, 2. And if we draw our curve, it's going to cross between 3 and 4. Let's draw our curve round through there, like so. And we get our inverse function here. So it's just a reflection of that line. We need to put thick dots at the end, because notice these are thick dots at the end of here. If there's an empty dot, meaning that you are strictly less than or strictly greater than that point and not including that point, then we need to put empty dots at the end there. Okay. One thing I just want to look at here is if we just look at the range and the domain of both. So let's look at f of x and let's look at f minus 1 of x. So this up here is f minus 1 of x we've drawn up here. So I'm going to write it the other way around. I'm going to put the domain first because that's what we put in, and put the range second. This is what we get out. So for f of x, our domain was between -1 and 4. So x is a member of the reals such that -1 is less than or equal to x is less than or equal to 4. Now our domain for inverse is from -5 all the way up to 2. So the domain for this one is x is a member of the reals such that -5 is less than or equal to x is less than or equal to 2. Now you should be able to just write out the range straight away. Okay, knowing what we've got here. So y is a member of the reals such that now the y values on f go from -5 all the way to 2. And then if we do y is a member of the reals for the inverse function. So for the inverse function, our y values go from -1 all the way up to 5. Up to 4, sorry. I knew what went wrong here. Sorry, I wondered why this graph looked a bit wobbly. If I just get a different rubber, let's go draw, let's change my small eraser. Just get rid of this bit. My line should have gone to here. That makes it look better. Sorry, there we go. I just plotted this one by mistake in the wrong place. So we're going to go from the point -1 is less than or equal to y is less than or equal to 4. So what we can see here is notice that the domain for the inverse function is the same as the range for our original function. And our domain for our original function is the same as our range for our inverse function. So domain and range will flip round between the real function and the inverse function. Okay, there's another question down here for you to have a go at, and it's all yours to practice before our next lesson.